Hello everyone, welcome to this class. In this class, we are going to treat how to find the trigonometry for 180, 270 and 360. We've already done 0 and 90 in the previous class. So this is a circle, this is a first quadrant, second quadrant, third quadrant and fourth quadrant. Starting from here, 0 to 90 first quadrant, 90 to 180 second, 180 to 270 third, while 270 to 360 is fourth. And this is the shortcut I gave us in the previous class to know which of them is positive. For those that didn't follow the class, I'll put the description in the link in the description below, so that you can go and touch the class and understand what we are doing here. Here, all of them are positive. Second quadrant, only sine is positive. Third quadrant, only tan is positive. While in fourth quadrant, only cos is positive. So now, from what we did in the previous class, sine 0 is 0, while sine 90 is 1. So the easiest way to get the answer is continue. Yes, this one stop in 1, so the next one will be 0, next one will be 1, next one will be 0. Let's stop here. You can do it for the higher angles, but this is where we are going to stop. You understand? Make sure you are following this order: 0, 90, that's you're adding 90 to it, plus 90, 180, plus 90, 270, plus 90, 360. So you can alternate and make sure you're not making a mistake. For the cos 0 is 1. We did it in our last class. Cos 90 is 0. So you continue in that angle. The next one, since here is 0, next one will be 1, 0, 1. Now, you've already gotten the answer to be 1 and 0s. Now, the next challenge you're going to have is, remember what I said, sine is only positive only in the first and second quadrant. This is A, meaning all of them are positive in the first quadrant. So sine is the only one that is positive in the second quadrant. So now we are dealing with sine. So you make sure that here now, this is third quadrant. So it's supposed to be negative. So you put the negative sign. So sine 270 is negative 1. For the cos own, we have 1 here. Normally you don't put negative in 0. That's why I'm not bothered about those ones. We have 1 here. And this is second quadrant. And from our second quadrant, cos is only positive in the fourth quadrant. So this one we have negative. We also have 1 here, which is fourth quadrant, and we all know that cos is positive in the fourth quadrant, so we'll leave it that way. So we've solved for sine and cos. You understand? These are things you're supposed to cram, but I'm just like trying to give you a shortcut on how you can easily remember them. So for tan, remember what we say, that tan is sine over cos. So 0 over 1 is 0. 1 over 0, remember what I said about any number divided by 0 is infinity or undefined. In case if you see undefined in any textbook, you know you are still saying the same. This is the sign for it. 0 over minus 1 is still 0. 1 over 0 is still, this is a number divided by 0 is still infinity. So this one is still undefined. While 0 over 1 is still 0. So this is the easiest way to find these ones. Let's assume I want to go beyond, this is beyond this scope, but let's assume plus 360 minus 90 is 450. This is beyond this scope, but let's just test ourselves. Since here is 0, the next one will be 1. Since here is 1, the next one will be 0. You understand? But here now, the only challenge you now have is how do you know when to put negative or not? That's why I said it's beyond this class. You understand? Here will be positive. You can check it on your calculator, but I'm not going to teach it in this class. Now you can talk about tan. Tan will now be 1 over 0. You still have your undefined, because any number divided by 0 is infinity or undefined. So the next thing I'm going to teach you, so the next thing we're going to do is the sine graph, cosine graph and tangent graph. For those wondering how I know that this one is positive, it's like you are repeating this again. This 450 is equivalent to this all, but I don't want to confuse us in this class, so let's just leave it. So let's go to graph, sine graph. Now for sine graph, we have something like this. We have 0 here. We all know that below the axis is negative. We have negative 1. We have positive 1. Mind you, I'm not drawing this into scale. This is 0, 1, 2, 3. So let me say 1, 2, 3. Let's put this negative 1 here, so it will look almost the same. So from here now, sine starts from 0. So we have something like this. I'll stop at 360 since our class today is on 360. Mind you, I'm not drawing this thing to scale, but I'll explain it. Here is 1. Here too is -1. So how do you know this graph? Here is 0. The middle of this, this is like a semicircle. So semicircle is 180 degrees. We already know that one. The middle of a semicircle is 90 degrees. Now this is another middle. Here will be 270 degrees. And here is 360 degrees. So from here now, you can also see that we are getting the same thing. Sine 0 is 0. Sine 90 is 1. Sine 180. Sine 180 is still 0. The next one is 270. Sine 270 is this. 1 minus 1. That's why I have -1. Then sine 360 is still 0. Now, I think this graph will also explain how I got this. The next 90. Let me draw it further. Here will be the next 90, which should be like 450. You can see it's still giving us 1. I think that one explains it better. But as I said, let's not go beyond the scope of our class. So this is a sine graph. This is another thing you can also use to remember the trigonometric values of all these. Mind you, we are solving all these things in degrees. There are also trig in radian, which is not in this class. So let's focus on what we are doing. In case if you see, sometimes when you punch your calculator, you get another value. It's just for you to check if your calculator is giving you the answer in degrees or it's giving it to you in radian. But this is not part of this class. You understand? So let me continue what I'm saying. I would have told you how to convert degree to radian, but I'm just trying to avoid putting things that are not meant for this class here. So this is for sine graph. Now let's go to cosine graph. Cosine graph. For cosine graph, let me draw it here. We have something like, let me say this is the graph. Okay, I'll try to make this one as scalable as possible. We have 1, 2, 3. Let me put this one as 1, 1, 2, 3. Let me put this one -1. Now for cosine graph, you start your wave sign from 1, unlike the sine graph where you started from 0. So start from 1. You draw like this. You go to your -1. You move up again and stop at 1. Now this is 0. This is like a quadrant of a circle, half of a diameter. This is 90. This is another centimeter. A semicircle, I mean to say. So the middle is 180. Here is 270, and here is 360. Now let's compare it with what we already have. Now cos 0 is 1. As you can see, 1, and this is the one here. This is cosine graph. Cos 90 is 0, which corresponds to what we got in the other class. Then cos 180 is -1, that's -1, which is still corresponding with what we get, -1. Then cos 270 is still 0 again. Cos 360 is 1. Sorry, this almost confused me. Because normally I was supposed to stop here, but I added this extra one, so that's why. Cos 370 is 1. So this is how you can also find it. But mind you, I want to say something. All these places are part of what we've done, but because I'm not focusing there, let me say, for example, you look for cos 60. Let me say 60 somewhere here. By the time you check it, you see that it corresponds to 0.5, which is what we get. But that's not what we are doing in this graph. But just know that all these things signifies an angle, and all these places signify an angle, and when you trace those angles up, you get the value, which will also correspond to what we've been doing since we started this class. But my focus is mostly on these special angles here. That's why I'm not talking about those ones. So this is the cosine graph. You understand? For tangent graph, I'll show you how it works. For tangent graph, you have something like this. Here is 0. Here is, let me say 1, 2, 3, 1. Let me say 1, 2, 3, minus 1. You have something like this. It starts from 0. It goes like this and stop. It keeps going, but we'll stop here. Then it starts from somewhere here again. Let me just draw a line like this. This is not touching this line. They are not touching each other. It's called asymptote. A line that they are getting closer, but they will never touch each other. Let me draw another one. You have something like this. We have another asymptote line here. Asymptote, they will never touch. Then we have another one again like this. So here is 0, here is 90, here is 180, here is 270, and here is 360. So what this graph is saying is, mind you, these two lines are not touching. They can never touch each other. That tan 0 is 0. Tan 90, since this line is going up and can never touch, is undefined. That's how you express it. I know some of you might be confused, but that's the graphical expression of that undefined term. Because you have an asymptote. Asymptote is a two lines that are getting closer, but no matter how far they go, they will never touch each other. So that's define the asymptote. Then tan 180 degrees is still 0. Mind you, as I said earlier, angles are here, and when you trace them up, you will still get, let me say for example, this is half. When you trace them up, you still get their values, but this is not part of what I want to focus in this graphical expression. I want to focus on these special angles. So cos tan 180 is still giving you 0. Let's check it. This is our tan 0, we get 0. This is our tan 90, we are getting infinity. This is our tan 180, is still 0 again, and this is tan 180, this is 0. Then next thing is tan 270, still infinity again. 270 is undefined. Then tan 360 is 0. We are getting 0 here. So this is how you express the graph of sine, tan, and cosine and cosine. These are the graph. This is a cosine graph. To refresh, start from 1 and then wave it. And tan is a special one. You just need to know it. And why sine? Sine and cos are the same, just the only difference that sine start from 0, while cos start from 1. So these are these ways you remember these values. You can use this method. What I do is some of the things I use have worked for me. I try to teach you. It's not like it's mathematical, just a way for you. It's like this cast here. It's like this thing I expressed it, just for you to remember them easily. Thank you, and see you in the next class.